Since now we have a clear idea of how our rig should behave, let's take a look on our guide skeleton. So let's start with the second rig. Then I go back because since I've changed some things for Edwin's model, it has some extra things that I haven't changed. So here is the word orientation for this and this joints, simple stuff. This is for the piston bottom, and as I said in the previous video, the main axis will be locked and it will depend on the rotation of this bottom cross here. So that's why here is our main axis, and this green axis will be our secondary, where it will rotate. So that's the same idea, that same concept that I just talked about in the previous video. So again, this is for the piston bottom, this part here. The piston top, it is the same thing. Here, our main axis that will be locked to the top cross, and here will be our secondary axis aligned along this. And here is the top cross, the primary axis, the same idea, it will be locked. Since this here is locked to the top, this will be tied to the top as well. Therefore, it won't change in relation to this part. And here is the secondary axis. As you see, since this is a box, it's right in the middle. So it looks like it's perfect. The same thing for the bottom part. And this, as I also said, that is not aligned to this because this should be perpendicular to the other two axes. So this is for the bottom cross, this part here with this kind of disc-shaped parts. And for the guides, as you see, there are a lot of extra things here, but in the end, I was able to simplify things. So for the piston bottom, since our main axis will be here, I just moved this joint here. It will act as our lookout. So piston bottom lookout, this one, and the lookout up will be here. You can see because it's on a viewport issue, but that's it. The same thing, but reversed for the top part. So here we have the joint for the lookout. So we will lock the main axis for this top part of the piston. And down here, it will be the lookout up. So that's what we see here, lookout up. And here the lookout. And for the top and bottom crosses, since our main axis will be locked here, this will be the joint for the main axis or our lookout direction. And this will drive the lookout up for the top part, the top cross. And here, to lock the primary axis for this top cross, we'll be using this joint to drive the primary direction, primary orientation. And here will be used for the bottom cross to the lookout. So pretty simple stuff, as you may see here, a lot of things I managed to simplify. So, and that's usually great news, because the simpler is our logic, the easier it is for us to debug, to fix, or to improve, in general, to change. And the parenting here, I think it's easier to show in the directory, because there are some overlapping joints. So for the bottom part, here we have this fixed base, that is this joint here, then the bottom cross, that is here, and as a child for this bottom cross will be the piston bottom, because the piston will rotate along with this bottom cross, and the piston look at, that is the main axis of the piston, because it will rotate as well with the bottom cross. So the bottom cross will rotate the piston and its main axis along with it, and the piston top look at, that is this one here, the top cross, that is here, the joint, the top cross joint, and the piston top joint, both will aim at here. So here we have the piston top look at up and top cross look at up as well. Both are parented to this, that is fixed. And the bottom cross, since it's fixed, it is a child of this joint as well. The same for the top part, but just reversed, same idea. So the main thing here is this. So the joints for the both this bottom piston and this top piston will be parented to their corresponding crosses. So for this bottom piston, it will be parented to this bottom cross here, again, the joint for the piston and the joint for the lookette, the same for the top part. So I hope it makes sense. Again, I'm deleting that because I managed to further simplify everything. And then let me show the spreadsheet. Text in name. So I'm creating these tags for the root and the top. So we'll be able to animate in the viewport, the root and the top. So here are the tags for the bottom cross. So for this bottom cross, I created this tag to be used as a pattern for the group to create a single look at for this. So this will be the target, look at up and look at. Here for the top cross, as you see, this is different to be able to be created in another loop, or in other words, another group of joints. And here for the piston bottom, let me just disable this so it will be easier to see. So this for the piston bottom, another look at constraint, and here for the piston top, another look at constraint, each one with this different pattern here again, so we'll be able to create the look at in a different loop. And that's why I'm duplicating the joints, so we won't have for the same group look at up and look at and things like that, because that will make a mess inside the loop, because you won't have a single joint when we do what I said. When we find intersection here, we will find more than one joint, and this will create a problem for us. So that's why I'm creating more joints than needed. Hopefully in the future, we'll be able to either use a clever way for managing this, or we'll have more features in Apex, so we'll be able to do the same thing with fewer joints. But anyway, I don't think this will end up creating some kind of bottleneck, because the general math is the same. It will need the same amount of matrices. It will be just a little more steps, especially if we want to output this guide's skeleton instead of the base skeleton. Otherwise, I think the calculations won't be much more than if we didn't use those extra joints. And here we are in the other model, Edwin's model. The same idea remains. The different thing here is just a naming convention, because when I first talked to Edwin, I thought that this part, what is it? This part here would rotate. And of course, I probably missed this, because it should make this lock to this part here. But anyway, in my first attempt of rigging this, I let this part rotate. And that's why this has this rotating top joint, but after the changes, this is not being able to rotate anymore. So I'm sorry, I kept the name, but it isn't actually rotating anymore. And here, since Edwin's managed to build this with different base orientation, you see that this may make more sense in this rest position than the other rig, but both will work the same. So this is for the piston top. So the piston top here will rotate along this blue axis. So that's why here will be the look at up direction, and this will be the look at. Again, this will be parented to this top cross here. So when this rotates along this axis here, it will rotate this top piston as well. Here, the same thing for the where's it? This is just for this part here, but actually this is not needed anymore. We can use the base orientation, so no need for some custom orientation for this part anymore, but I left that. And here is this orientation for our top cross. As you see, this is locked because this part is locked to this part here. So it will rotate along this axis, and this is its up direction, its up vector, and the same thing for the other part, the bottom cross. So same idea here. So same thing as well. Let me just remove this. Not sure about. Probably this is something related to the Python state of it, since this is turned on. Let me just, yeah, probably is that. And again, this was further simplified. If we take a look at the rig tree, same idea. For the top cross, we're parenting the top piston and the top lookat, the main axis of the top piston, because the top cross will drive it. And for the bottom part, the same thing. The bottom cross will drive the piston bottom and the piston bottom lookat, or in other words, the main axis of the bottom piston. Everything else will be a child of their corresponding locked parts. Same thing here for the tag system. And that's it. So in the next and final video, we will take a look at the rig itself.